Given a rectangular paved area 150 meter by 450 meters has a longitudinal drain along one of its longer edge, that is, this is the drain which is present along the 450 meter length. The time of concentration for the area is estimated at 30 minutes. TC is 30 minutes, consisting of 25 minutes for overland flow across the pavement. That is, if we take points A, B, C and D, time taken from B to A and time taken from C to D is given as 25 minutes, whereas time taken from A to D is given as 5 minutes through the drain. The total TC is 30 minutes, in which dividing it into 5, 10, 15, 20, 25 and 30 minutes interval. These blue lines are isochrones, that is points joining equal time of concentration, that is 5 minutes, 10 minutes, 15, 20, 25. Then the area gets divided into 1, 2, 3, 4, 5 and 6 parts, in which A1 area will be equal to half into bases. These are divided into, this 150 meters is divided into 5 parts, so each part will be 30 meters. So half into base is 30 into the height is 450 meters. So that will be equal to 6750 meters square. Whereas the other middle areas 2, 3, 4 and 5 will be equal, which will be equal to 2 times the triangular area, that is 2 times the 6750, which will be equal to 13500 meters square, and the final area A6 will be 6750 meters square. We know QP will be equal to C into A into I. That implies QP of 1 will be equal to C into A1 into I, where I is intensity of rainfall, which is given as 7 centimeter per hour, and C is given as 0.8. Substituting C as 0.8 into A1 is 6750 in meter square into 7, converting it into meters, it is into 10 power minus 2 meter by, it is 7 centimeter per hour, converting into seconds, it will be 60 square seconds, that is equal to 0.105 meter cube per second. Whereas others peak discharges QP 2, 3, 4 and 5 will be equal, since area is equal. There will be 0.8 into 13500 into 7 into 10 power minus 2 by 60 square, that is equal to 0.21 meter cube per second, whereas the last QP 6 will be same as QP1, that is 0.105 meter cube per second. So tabulating it, time and 5 minutes rainfall. In 0 minutes 0 will be the rainfall obtained. In 5 minutes the area, that is A1 area rainfall, that is QP1 will be obtained. In 10 minutes 0.21, that is QP2 will be obtained. In 15 minutes QP3 will be obtained. In 20 minutes QP4 will be obtained. In 25 minutes QP5 will be obtained, and in 30 minutes QP6, that is 0.105 will be obtained, and 35 minutes 0 rainfall will exist. In the next 10 minutes of rainfall, it will be lagged by 5 minutes, that is 0.105, 0.21, 0.21, 0.21 and 0.105, sorry 0.21 and 0.105, and then 0. In the next 15 minutes again it is lagged from 0, 0.105, 0.21 and so on. 15, 20 minutes, 25, 30, 35 and 40 minutes, it is finally lagged, and then the tabulated value, out of which the peak value will be at 30 minutes, which is equal to 0.105 plus 0.21 plus 0.21 plus 0.21 plus 0.21 plus 0.105, that is equal to 1.05 meter cube per second. So drawing it in a hyetograph form, the peak value will be 1.05 meter cube per second, that is at 30 minutes, and which is constant for next two values, that is for 35 until 40 it is constant, it is starting from 0, whereas the 5 minutes ISO, we need to draw the 5 minutes isochrones and also peak value we need to find, and it is drawn in this format, in which here it is 0.21 and here it is 0.105. This is 5-minute rainfall data. This is the final peak value.